recall the argument I had presented yesterday regarding conservation of momentum. How simple the entire thing is going to look at if I look at it from four momentum. Consider two particles, A and B. So P mu A is the forward momentum of particle P mu B is the forward momentum of particle. In collision, what is it that I want? In collision, I want P mu A plus P mu B. Say this is before collision. Becomes Q mu A plus Q mu B after collision. So what do I want? I want this to be equal to this. Once it is equal in one frame, then I can write P prime mu A, P prime mu B. But what is P prime mu A? It is the lambda mu nu. And lambda mu nu does not depend upon P or P. It just depends upon the Lorentz transformation that I made. So if this, the argument is that left hand side is a 4 vector, right hand side is a 4 vector. The transformation property of both of them are the same. Therefore, if it is true in one frame, it is going to be true in all frames. I don't have to check anything further. All I need is, I must ensure I write 4 vector here and a 4 vector there. That is the virtue of it. Had I written something which didn't transform as a 4 vector, then that particular one will cost me problems. Just like when I introduced a magnetic monopole charge, under parity that transformed differently compared to the electric charge. The field, electric field and magnetic field transform differently. Therefore, it was not invariant under parity. Now, this will be invariant under the Lorentz transformation. So I don't have to check anything further than this. Are these statements made? Now, let me check what is the zeroth component here. P0 is mc by 1 p squared by c squared. This is mc squared by square root of 1 p squared by c squared. If you remember, yesterday when I had worked, I had associated by c. I had associated with this with the entire energy of the particle, including its rest energy. So this is E by C, where E represents the complete energy of the particle. We had argued our way through there. In fact, I had worked out the work done and so on. There I had found if I expand it, this will become mc squared plus half mv squared, and half of v squared was the kinetic energy. M0, this is M0. So I have to keep track of my M0. So I should, this is the total energy, M0 C squared would just be the rest energy. So what is P squared? Let's calculate now P squared. E0 squared minus E1 squared minus E2 squared E3 squared is M0 squared into E0 squared minus E1 squared minus E2 squared. This is equal. We have already seen this quantity was C squared. But this is E squared by C squared minus E squared. We get an extremely important relation between C squared. This is a very big. For massless particles, I get E equal to C. Notice, for a massless particle, velocity is not a good way of thinking. Why? Because if I want my energy for a massless particle to be finite, m0 is 0, then only way in which this can be made finite is V must be equal to C. So, as far as the massless particle is concerned, it will always travel with the velocity of light. So therefore, velocity itself is not a good way to try to find out, to categorize a massless particle. The massless particle is characterized by its momentum or its energy, and of course they are related by E equal to C. So for massless particles, it is better to think in terms of momentum or energy, okay, instead of velocity. So that is another thing which you should keep track of. Now I come to getting to forces.
So what is about the negative part?
Negative?
That E square is equal to C square D square.
Okay, so that's right. So you are saying, what is the meaning of this? We will only take the positive square root C squared D squared plus M0 squared. We will not talk about the negative energies. Now, presence of forces, so I will write down that relativistic dynamics. Suppose no force is there. Let me start. Then momentum should be conserved. So I will write it as d mu dp mu by d tau equal to 0. Once it is true in one frame, it will be true in all frames. Now comes, how do we improve force? I know the answers are okay when I do the non-relativistic one, and I must be able to write down a relativistic generalization of that. So I will write it down, d p mu by d tau equal to F mu, where F mu is a 4 force. So I have to define what is a 4 force. Only then I will be able to manage to do things. So if I take the definition F vector is dp dt from here. Then from here f vector would be dp d tau times d tau by dt. Sorry, did I write it correctly? F is dp d tau. This is my force, which is dp dt times dt d tau, which is f times d. So my components of f mu are f0. We will find out what is f0 in a minute. This is gamma. Let's now take an example. If I have a particle, charged particle, moving in a magnetic field, then my F for a charged particle moving in a magnetic field, Q times V. We know this. So I am going to assume this is valid also in the case of special relativity. So if I take that, I would get my dp dt to be equals q times v force. But what is my p? I have already written down an expression for p. It's diagram d tau. P was actually it is m0 u, which is m0 v by 1 v squared by 6. I will tell you, after doing it, tell you what are the ambiguities possible. So I can substitute now this here. So I get m0 times d v.
What are you and
U is, I had already written down my code. What was my definition of P mu? P mu was m0 u mu. Right? And what is u mu? U mu was u0, and instead of writing u1, u2, u3, I just wrote it as u vector. Okay? Who asked this question? Is it okay? So that's my P was defined as m0 u, and this is the expression that I have as well. With V, if V is the velocity associated with it, then I had already written that. Earlier, if you go back your notes, you will see that u vector is essentially gamma v vector. So if V is the velocity of the particle. Right now, everything is being done in one frame. I don't ever go to the next frame because I can always do the check whether I have a 4 vector on both sides, then I don't even bother to go. So that's the thing. Now I am working everything in one frame. There's a particle moving with a velocity v. This is all, and it is experiencing, of course, v cross t. So I write down here, I'm going to solve this equation. Write down m v d dt of m0 v by square root of 1 v squared by 6 equal to q times v times. multiply, dot it with V. When I dot it with V, what will I get? I will get M0 V dot dd of M0 gamma. I have rewritten this as gamma. This is, so I have written M0 twice. Yes.
Where P is equal to mu, that equation. Sir, P is equal to mu.
Did I make a mistake? Where? Which equation?
M not that. P is equal to M not.
V. Yeah, what is it? Which step? Is it okay? From here, I need your help to prove that V is constant. Okay. I will leave it to you. You can go ahead and prove that. So if V is constant, I have here, I can move this outside and go back to writing this as M0 divided by 1 minus V squared by C squared dV. V is constant, which is Q times okay. Because V is constant, V squared can be put. So, if I treat this as a new mass, this problem goes back to the standard non-relativistic problem that one solves with V cross B. So, the only new thing that has happened for the problem is the mass should be replaced by m by square root of 1 minus V squared by C squared. So, if I want to, we all know what is the motion of a particle in a constant magnetic field. It is a circular motion. So, we know the formula is just mv squared by r is equal to EVV. Because in fact the motion is perpendicular, so V is not, or if I want to write r from here, r would be mv by. So, what is the difference? This m now should be replaced, this m should be thought of as a function of mass. So this I will write it as m0 divided by 1 minus V squared by C squared. That's the answer. Now,
Can you call it say mass
Pardon?
renormalization?
pardon?
Mass renormalization?
Mass is a different mass for a moving, for a particle, right? Mass is to be replaced by m with this extra factors. Notice the crucial thing I am assuming is that the force is given by this equation. How do I know this is the correct equation? Only when you know it is experimental. I can write another equation, non-relativistic equation, put square root of 1 minus V squared by C squared here. That this is the correct equation. So ultimately, the proof of it is in experiment, but there is more to it than that. Later on, Professor Rangawala will show you that this equation that I have written, which looks not particularly covariant, comes from a covariant equation. And the covariant equation I will write down here, and I will leave it to Professor Rangawala to show this. This will be equal to F mu lambda J lambda J sigma eta lambda, where it will be F mu lambda would be a second rank antisymmetric tensor connecting electric and magnetic field, and J is the current. So this will be the covariant form of this specific equation that I am writing. So ultimately, the choice whether I use V or V divided by 1 minus V squared by C squared are dictated by two things. one by experiment, and since this is the choice which gives rise to a very nice form where the left hand side is a vector and so is the right hand side a combination. Notice here I need the QV is essentially the current associated with the charged particle, and that current is the current here. Current again has been written as a 4 current, and this is the electric and the magnetic field which come. The moment I write down this in the non-relativistic version, when I go to the non-relativistic form, this goes to dP by dt Q times electric field, the standard equation that you write. V is the standard V, dx by dt. This P is the 3 components of the 4 momentum vector. This is the connect equation which leads to the covariant form. That requires the electromagnetic theory to prove this expression. Okay? So right now, this is the electrodynamics that we have. Finally, I just want to write down a few more things and then we will stop after that. How does force transform under Norton's transformation? Not the 4 force, but this force. Fx, the 3 force, Fx prime, is dpx prime by dt. This is gamma dpx minus beta times dp0 divided by gamma dt minus beta by c. Which is, I write dt outside, so this is dt outside, minus dp0 by dt divided by 1 minus dx plus 1. But this P0 we have already seen is E by C. So I write down this as Fx minus beta E by C. You can see it is not a very simple expression. Minus beta by C.
UX.
Right. Similarly, Fx prime Fy prime is Fy sorry is dp, let me write it down, dp prime by dt prime is equal to dpy by gamma times dt minus beta dx by c squared, which is, I take out dt, so that will become Fy divided by gamma times 1.
So we have C square. Here it is beta C.
Beta c, right? Because I have absorbed one more. This is. So, if ux, uy, uz is 0, that is force in the rest frame, then notice fx prime, force in the rest frame of the particle, it just becomes fx prime in the rest frame. I get fx prime is fx
minus
beta 1 by c, and fy prime fy bar. No, this is not correct. I made a mistake here. This is dE by dt, right? I have to substitute not E by C, so I have to write here dE by dt. I have to write what is dE. So dE dt is fx minus beta by c times f dot power. dE dt is the power, is nothing but f dot. So when I put this 0, this is nothing but fx. So if there is a force in the rest frame, the force along the parallel direction of the rest frame remains the same, perpendicular directions contracts, right? I think you people have got some feel for how relativistic dynamics is handled. Now, of course, you have to do many problems, then you will get a better feel. I guess this is a good place to start.